Hello, I am Elrenn of the Oro and I'm here to introduce our chosen structure to provide an estimate with the schedule and bill of quantities. So here we have our chosen structure with plans, and keep in mind that we have simplified it in our estimate so that we could estimate it with guidance from the lecture class. So here we have the plans. We have the roof plan, the ground floor plan, the second floor plan, the elevations, the right side elevations, the cross section, and the longitudinal section. We have the schedule of doors and windows. So this is our included in our bill of quantities, and to determine the amount we counted it from here, from the different elevations. So further explanations here will be provided further later on. Then we have the foundation plans, as you can see right here. Then there are some notes here: 100 millimeter thick concrete slab on fill with rebar spaced at 600 millimeters. And we have the floor framing plans, beam details, as well as column and footings. Then stairs, we did not include the stairs. Then the master development plan. Here we have the CHB details front. So we use this 400 millimeter by 200 millimeter concrete hollow blocks as our chosen CHB. Then we got the area of the wall, so with minus the openings from the windows and doors, and as well as the garage door openings. Then it will be shown further on in our calculations. So just a quick run through of our plans will be presented in this section. Then we have the floor tile layout plans. Oh, it's lagging. Tile layout plans. We did not include any estimates regarding electrical, so skip this, as well as plumbing we did not include. Then schedules are rather, yes, as schedules of the different beams and as well as columns. So moving on, we have here our calculations. So I did the an estimate on the concrete rebars, some of the rebars, and as well as for the paint. So firstly we have the concrete. So I gathered the volumes for the footing, columns, and for the slab on fill. Then which is given by these dimensions right here. Then multiply that to get the volume. Then in the plans there was 16 footings. Then we did so with this was just manually counted from the plan right here, 16 of footings. Then we multiply that for the volume of the six for a single footing, then we got 8.41 cubic meter. And for the columns, there were three different types of columns, so I labeled them C1, C2, and S1. So the C2 is a shorter column than the S1, stands for support column 1. It was in an even smaller column. So, but the dimensions were the same. It was only a height that was different between each of them. So we calculated that right here. Then we multiply by the amount. Then add all three. Then we have this value right here. Then for the slab on fill, it was basically just a square shape of the total area of the plan of the house. So just right here, 11 meters by 11 meters. Then we have a thickness of 0.1 meters. Then we multiply that. Then we get 12.1 cubic meter. Cubic meter. And for we had the footing molds, we used a 0.9 times 0.1 1.2 meter times a half-inch thick plywood. So we gathered the area, side A and side B. Then we multiply that by the half the amount of footings, which is 16. So that would be 8. This is for, so there would be 12 plywoods needed for 8 footings. Then for the coco lumber, we used 2 inch by 2 inch by 12 foot coco lumber. And here the calculations. Then for 1 footing, we needed 2 coco lumber. Then for 8 molds, we needed 16. So okay. Then we have footing rebars. Oh, it was shown where in the plan, the right here. That's right. So it is a 1 2 3 4 5 6 7 7 by 7 grid of rebar. So we do that. Then we concrete covers the diameter of the bar. It is all calculated right here. Then we got 21.36 meter for one rebar. Then multiply that by 16, which is for all of the footings, then divided by 6. So we needed 57 pieces of 6 meter rebars for all of the footings. So for beams rebar, then this is not my part. So for the slab fill rebars, this was just presented in the plan right here. Spacing, which is 0.6 millimeter. So the 11 meters divided by 0.6, so it yields 19 layers. Then same for the vertical, then we multiply 19 by 11, which is the meters, horizontal distance and the vertical distance. So we had here, that is a meter, then total length of rebars, then we divided by 6. So we need approximately 70 pieces of rebar for the slab fill rebars.
Hi, my name is Neil Brian Tabaranza, and what I did was get the length, total length of rebars and stirrups, and also total weight of tie wires that were used for the columns and the beams. So what I did first was get all the lengths of all the beams and all the columns and the height of the columns, and I multiplied it by 4 so I can get the total length of the rebars and eye rebars used. So next what I did was for the stirrups, I counted all the stirrups from each beam and each column because it would have been easier for it would have been more specific, although solving for it would have been more it would have been more efficient in time. but what I did was count them all to be more accurate. And lastly, to get the tie wires is I just, since I counted already all the stirrups, since there are four intersections of stirrups, and I in each stirrup and for rebars, I just took all the number of stirrups I got, and I multiplied it by four, and yeah, and I multiplied it by 0.3 so I can get the length, and divide it by 4.93 to get the weight of the tie wires to be used. Thank you.
Okay, moving on. For my part, I calculated the CHB. So here we have the calculations for the area. I based this on the front view, left view, right view, and rear views of the plate, which is basically the elevations presented in the plate here. And to get the area, I used the area method. Then, by getting the areas of each views or elevations, I removed the area of the openings right here. So for example, we have different elevations, then I remove the area of these openings right here, then subtracted it to the total area, then we get the final area. I did this for each side of the structure. Then the sum here is 1554.13 cubic meter. This is cubic meter. Then that's only for the exterior wall. Then we divide that by the area of the CHB, which is right here. 0.4 times 0.2 is equal to 0.08 cubic meter, rather square meter of CHB. Then we divide that, then the total final area of the walls I divided by right here. So that is not cubic meter, I'm sorry, square meter. I divide that by right here, then we get 19,937 pieces of CHP. Then for plaster, we decided we used 0.015 millimeter thickness for the plaster. So we multiply the total area of the walls by the thickness, then we multiply that for 2, so we get 2 sides of plaster. So we have here the total volume of plaster. So for the mortar fill, we use this picture right here, the core area, the core volume. Then we did here required mortar fill for core. So to get the required mortar fill for core, I multiply the number of CHB by the core volume, so which yields this value. Then for the mortar layer thickness, the mortar in between the layers of CHB, then we get here. Then we add that together, we have the total required mortar fill. Then lastly, for the CHB, we have here the calculations. So we assumed the spacing of 400 meters and for 3 layers. So we have here the calculations. Then we I use the ratio and proportion right here. So I got the shape 1, which is just one smaller shape right here on the of the structure. Then I we did the ratio proportion procedure to the total area to get the area total number of rebar for CHB right here. So this is basically the ratio of area to length of rebar. So I ratioed it to the total area, which is 154.13. Then we have the total length of rebar for CHP. Then we divide it by 6. Then we get the total number of rebar for CHP, which is 691 pieces. That's meter. So lastly, we have here the paint. So this is just the sum of total area of walls. So the exterior area of walls right here is 154.13. Then we have the interior area, which is 79.3 for the first floor. Then we have 100 for second floor. Then we add that together. We have the total area of walls, which is 353.69 meters squared. Then we divide that for a constant. So we assumed a fine to coarse surface. So it is 35 square meter per gallon. So we divide the total area by the square meter. So we get 9.53 for 4 gallons for concrete primer and the paint. And for the number of gallons for paint, 10. So this is just what we need for um, the paint. So basically this is just similar. So that is it.
Hello, Sir William. I am the next presenter, Rikki Tayo. I'm going to talk about my task, which is to calculate or solve the interior parts and design the tile, tiles, tile adhesive, cement mortar, grout, including the paint and paver. So starting off with the tiles, here we have layout plans for the first floor and second floor. So first off, we will start by first floor or the ground floor. I'm going to use the area method and divide each areas into three. Where here is area 1, area 2, and area 3. So note that for area 2, this is not a square. This is still a rectangle based on uneven dimensions of the length and width. Next is you will first talk about the area 1, which is the rectangle shown the topmost of the floor plan. We have a length of 11 meters, width of 3.8 meters, and assumed grout size of 0.001 meter, and having a tile size of 0.3 meters by 0.3 meters. In order to get the total area, we're going to multiply the length by its width. And to get the tile area, we're going to multiply the grout size with the tile size times itself. To get we have a total area of 41.8 square meters and a tile area of 0.09 cubic meters, square meters. For the number of tiles, we're going to divide the total area with its tile area. And that's why we have number of tiles of 461 pieces of tiles. To get the box needed, we included this to assume one box is equals to 18 tiles inside one box. So for the number of boxes, we're going to divide the number of tiles with the assumed box, 18 tiles in a box. So you have 26 boxes needed to cater 461 pieces of tiles. Same for area 2. We're going to have this length and width used, which are 6.675 meters, 5.95 meters. Grout size would be the same and the tile size would be the same. Having an area which is equal to 38.65 square meters. And this is done by multiplying the length and the width of this area, the area of a rectangle, and subtract it by this area, since it is not included in area 2, and add this area for area 2. That's why we have these dimensions, which are 2.871 meters by 0.95 meters for the porch. And for the left side of the area 2, we have 2.650 meters by 0.95 meters. Have a 427 pieces of tiles for area 2 and having to cater 24 boxes. For area 3, which is the porch side, we have a length of 3.15 meters, a width of 2.05 meters, with the same grout size and tile size, that we have this multiplying the length and the width of the area. So we have a total area of 6.34 square meters and a tile size of 0.09 square meters. So we have a total number of tiles of 70 pieces and 4 boxes. It's also being considered these areas of area 3, 0.6 meters by 0.6 meters and 0.8 meters by 0.3 meters, which can be seen in this part first and the second part. Next is we will get the grout. The grout, as assumed during the class, we let this as our standard. 1 kilogram is equal to 30 square meters. So 1 kilogram, 30 square meters. To get the grout, we're going to divide and multiply. We're going to multiply the 1 kilogram by its total area, area 1, and divide it by 30 meters by using ratio and proportion. So we have 1.39 kilograms. For area 2, we have 1.29 kilograms. And for area 3, we have 0.21 kilograms, having a total grout of 2.89 kilograms. Next part is for the second floor tile layout plan. Given this illustration for the area method, we have area 1. In here, we're going to also add this rectangular part or shape to the area 1. Area 2, simple since it is just a rectangle. And for area 3, we're going to use a rectangle and add this part to get the area. So for area 1, we have a length 11 meters, width of 3.8, same grout size. Get the area, going to multiply the length and the width plus this this part or this dimension, which is found at the top side, left corner top side of the plan, which has a dimension of 3.650 meters by 1.125 meters. We have a total area of 45.91 square meters, and a tile area of 0.909 square meters. Finally, we have a number of tiles, which is 507 pieces of tiles, and having to cater one box is equals to 18 tiles. We have 28 boxes. So for area 2, this area of the second floor, we have a length of 3.2 meters, a width of 2.475 meters, the same grout size and tile size. We have a total area of 12.02625 square meters and a tile area of 0.09 square meters, creating this total area divided by the tile area. We have 133 pieces of tiles catering 7 boxes. Area 3, we have a length of 9.75 meters, a width of 3.75 meters with the same grout and tile size, and have an area of 42.87 square meters and a tile area of 0.09 square meters, having to equate it to 473 pieces of tiles and 26 boxes. To get the grout, same thing with the first area, area 1. Going to use this standard, use ratio proportion, and the area we have solved to get this grout. For area 1, we have 1.53 kilogram. Area 2, we have 0.53 kilogram. And area 3, we will be needing 1.43 kilogram. And a total for area this for the second floor is 3.49 kilograms. And to get the cement mortar, white cement filler, and tile adhesive, we're going to use this given data. The wall area, which is equal to 32.923 square meters, floor area of 41.8 square meters, with a total area of 74.723 square meters. To get the cement mortar, we're going to multiply the total area by the standard of the cement mortar, which is 0.086 for bags. And while for the white cement filler, total area times the standard for white cement filler, which is 0.5, and the tile size is total area times 0.11 bags. That's why we'll be needing 6 bags of cement mortar, 37 kilograms for white cement filler, and 8 bags for the tile adhesive for area 1 for the first floor. For the second floor, for the area 2 of the first floor, we have we have solved the same process. We have 5 bags for cement mortar, 29 kilograms white cement filler, and tile adhesive of 6 bags. And lastly, for the area 3 of the first floor, we'll be needing 1 bag, 8 kilogram of white cement filler, and 2 bags for tile adhesive. Same thing with the second floor. Using this same process, we will get 7 bags, 38 kilogram, and 8 bags for the 3 following cement mortar. And for the area 2 of the second floor, we need 2 bags of cement mortar, 12 kilogram of white cement filler, 3 bags of tile adhesive. Lastly, 6 bags for cement mortar for area 3 of the second floor, 35 kilogram for white cement filler, and 8 bags tile adhesive. So in summary, the total cement mortar that we will be needing are 27 bags. For the white cement filler is 159 kilograms. Tile adhesive is 35 bags. And for the grout, we have 6.38 kilograms. So the purpose of solving this is to be able to efficiently use all the materials for um using the tiles for the first floor layout and the second floor layout. And remember that if you're not that familiar with the parts, we know that for a short discussion, cement mortars are used as a base layer for the tiles, providing a stable foundation. And the quality needed can be calculated based on the total area to be tiled and the thickness of the mortar layer. The white cement may be used for specific applications such as installing light colored tiles or just for aesthetic purposes. And for the grout, it is very essential since it fills the gaps between tiles and it provides a finished look and preventing moisture penetration. And by considering all of these, we will have a systematic approach, of course, that considers the measurements, and also you won't be able to waste any material, and the properties of each material ensures an efficient and successful tiling project for this specific house. So next, let's move on to designing or solving the paint and paver. So as shown, there is no paver for this building plan since for some reasons the absence of pavers in this house could stem from various reasons, including personal preference, budget, yes, the budget considerations, and intended use of outdoor spaces. Since pavers are commonly used for outdoor landscaping to create a more durable, appealing, appealing surfaces, this owner might opt for an alternative material such as concrete, gravel, or natural stone based on factors like maintenance, um, climate considerations, and design preferences. So we will only be solving for the paint. For the paint, let's assume a fine to coarse surface and having a 35 square meters per gallon. So the total area of the walls is 333.69 square meters. And to solve for the number of gallons, 1 gallon or 4 liters is equal to 35 square meters. To get the number of gallons, we are going to multiply total area with um 1 gallon over 35 square meters by ratio and proportion. And one neutralize next, so that we have 10 gallons. We'll need 10 gallons. And next is a one neutralizer is mixed with a total of 2.5 gallons of water to get the number of quarts or quartz neutralizer. We're going to divide the number of gallons, 10 gallons, by 2.5 to get 4 quarts neutralizer. Next is to refer to section 10-6. We have a total primer, which is get I solve by dividing the total final area of walls by the standard for paint, which is 35 square meters per gallon. And the same process for getting the acrylic gloss latex paint final coating for um the building plan, the structure itself. So that in conclusion, we have a total of 4 quarts neutralizer, concrete primer of total of 9.54 gallons or 53 gallons, and an acrylic gloss latex paint final coating in order to prevent cracking. If I assume we have 9.5534 gallons as well. So ultimately, this also have the same purpose, which is to prevent wastage. That is the most um, economical and reasonable analysis why we solve for these things or estimating these things or materials. That is it for my presentation. Thank you so much.
So, good day, sir. I am Daniel Justin Padilla, and today I am going to explain to you the ceiling works. And the way pag-solve na ko ani sa ceiling works is just like what you have explained during classes. A gypsum board or any kind of board has runners, carry channels, double furrings, and the clips. Clips which is the kanang intersection sa kanang carry channel of furrings. So to start, here is the ceiling plan or ang ceiling itsura sa atop. So what I did is kada square is considered as one shape. So all in all, there are 7 shapes, and kada shape na sa AutoCAD file ang sukod nila, which is ang length ug ang width, and get the area. And pagkuha sa runners is basically the perimeter of the ceiling of the shape. And to get the carry channel is basically kuha sa nimo ang spacing, ang specific spacing per kanang horizontal o vertical. So akong gibuhat ani is C1. C1 is the kunyata ni is the length. C22. Oh yes, is the length, and C2 is the width. And divide na nimo, and to get the LCC total, you just multiply these values to the length and width, and you add them all together, and maabot ta og 11 meters. So to get the double furring sa dayon is we just divide it with 0.5, which is the spacing. And pag divide nimo, you have this LDF1, double furring 1 is the length. Sakto ba ko? C22. Sakto. And the double furring 2 is the width dayon. And you add them. Ang pagkuha din sa double furring na total is you just divide the double furring to the specific length or width, depending on which number you are, and then you add them all together and maabot na. And to get the number of clips is you just multiply the double furring 1 or the vertical and the double furring horizontal, and wala na. That's how you get the runners, carry channel, double furring, and the number of clips. And ang gibot ang process ani gi-repeat rin ako shape 1 hangtod mo man ko, and you add all the colored kanisi runners, carry channel, double furring, clips, and maabot ta ani nga value which is sa tibuok ko na ni, tibuok ceiling na ni sa balay. And mao na. That's how you basically get that. So mao na sir. So good day sir. I am Daniel Justin Padilla, and today I'm going to explain the roofing of the of our plan. And to start, pagbuhat aning roofing is basically basihan nimo sa shape which was stated sa ceiling works. Kada rectangle is or square day has its own shape. So gibuhat ani, kuha na ko ang basically dimensions sa a specific shape. When you get that, you get the area. And ang pagkuha din sa pieces is basically i-divide ra nimo sa effective area which is 2.31. And yes, basically nanara pagkuha sa GI sheets ani. So 5 pieces for that specific shape. I-repeat ra nako antod mahuman ko sa tanan shapes antod mahuman abot og 7. And to get this rivets is i-multiply ra nako ang total pieces sa shape by 26. And yes, and stated here is the summary of materials. And wala na siya. Antod na din na sa shape 7. Wala na siya.
Hello everyone, my name is May Cho Gerong, and I have been assigned the task of creating a master schedule plan and organizing the manpower arrangement for our project titled A Proposed Two-Story Residential Building located in Ponteverde, Buhangin, Davao City. Today, I would like to walk you through the process of developing a master schedule and the strategic logic behind manpower arrangement. Task overview. As the project planner, my primary responsibility is to ensure that our project progresses smoothly and efficiently from inception to completion. This involves meticulously planning each phase of the project and strategically allocating our workforce to optimize productivity and meet our deadlines. So, creating a master schedule. A master schedule plan is a comprehensive timeline that outlines all the tasks and activities involved in a project. So here's how I approached this task. Number one is to define the project scope. So we have to understand the full scope of the project, including all deliverables, milestones, and objectives. And also, we have to gather detailed requirements from stakeholders to ensure all aspects of the project are covered. Number two is to break down the work. So we have to divide the project into manageable phases and tasks, such as site preparation, foundation work, structural work, and the finishing work. Number three is to estimate durations. We have to estimate the time required for each task based on past projects. And also, we have to consider potential risks and add buffer times where it is necessary. Number four is to sequence the tasks. We have to determine the logical order of tasks and identify dependencies. Example, foundation work must precede the structural framework. And last but not the least is to finally create the schedule. So we have to utilize project management software, example, Microsoft Project or Primavera, to create a Gantt chart that visually represents the timeline of tasks. So in our case, we used Google Sheets. And then we also have to ensure the schedule aligns with the project's start and end dates. Hello again, my name is May Gerong, and I was also tasked to do the manpower arrangement. So, manpower arrangement involves the strategic allocation and management of the workforce to ensure that the project is completed efficiently. So, here is the process. Number one is to assess manpower requirements. So, we have to identify the skills and number of workers needed for each task. And we also have to consider the availability and expertise of the workforce. Number two is to develop a resource plan. So create a detailed plan that specifies the number and type of workers needed at different stages of the project. Schedule workers based on their skills and task requirements, ensuring that the right personnel are available at the right time. So in our case here, we can see that the types of manpower that we used are the foreman, mason, welder, electrician, plumber, painter, and laborer. And so moving on with number three, we have to allocate resources. So assign workers to tasks based on their skills and availability. And ensure there is a balance between the workload and the workforce to prevent bottlenecks and overutilization. And last but not the least is to monitor and adjust. So we have to continuously monitor the progress of the project and the performance of the workforce and make adjustments to the manpower arrangements as needed to address any issues or changes in the project scope. So here, as you can see, we also included the power tools of our project, which are the jigsaw, electric drill, mini electric mixer, single bagger mixer, welding machine, electric jackhammer, concrete vibrator, and plate compactor. So moving on with the logic behind our manpower arrangement. So the logic of creating the manpower arrangement lies in optimizing resources, time, and cost. And here are the key principles. Number one is efficiency. By carefully planning and sequencing tasks, we minimize downtime and ensure that each phase of the project flows seamlessly into the next. Number two is resource optimization. Strategic allocation of manpower ensures that the right skills are available when needed, preventing delays and maximizing productivity. Number three is risk management. Including buffer times and continuously monitoring progress helps mitigate risks and handle unforeseen challenges effectively. And lastly is accountability. A detailed schedule and resource plan create clear expectations and accountability for all team members, facilitating better coordination and communication. And so, by adhering to these principles, we can achieve a well organized, timely, and cost effective project execution. We as a group are committed to ensuring that our project runs smoothly and meets all the goals and deadlines. And so thank you for your attention, and that would be all for the manpower arrangement.